Earthquakes are quite common and frequent natural phenomenon. Earth is divided into three parts: the core, the mantle, and the crust. Earthquakes are usually defined as two blocks slipping past one another in the utmost layer, the crust. Huge amount of energy is released during the ground shake. Compressive waves with push or pull effects and strain waves with sideway effects are sent out, which are called P wave and S wave respectively. The plate boundaries are made up of many faults, and most of the earthquakes occur on these faults. Workshop 1. The O'Higgins Tower. The tower is destroyed during the earthquake. There is a collapse in the midsection of the tower because of different stiffness between the two sides of the structure. To keep the construction standing on an earthquake, bracing can be added in the bottom story, which will stop the structure from falling to the middle and to both sides. In the test of a building model, bracing mostly prevents the structure from collapsing. Also, the columns are strong and they have similar stiffness, which can protect the structures very well. Workshop 2. Las Palmas Tailing Dam. Las Palmas Tailing Dam, locating 133 kilometers far from the earthquake's epicenter, has collapsed the most during the 2010 Chile earthquake. It failed due to its granular soil material. The granular soil comprised of sediments or other unconsolidated accumulation of particles, like gravel or sand, with insignificant proportion of fines, and friction angle phi in granular soils is the maximum inclination the slope formed by granular soil can have under gravity load. The angle beta is the actual slope angle. In order to improve the stability of the dam, factor of safety should be larger than 1, which means that the friction angle should be higher than the slope angle. The higher the factor of safety, the more stability the dam will have. Workshop 3. National Stadium. Emergency evacuation plans are developed to ensure the safety of lives under an ongoing threat. Proper planning is related to scenarios which include problems that may occur during an accident. For example, overcrowded people, mix of cars and pedestrians, unclear signage and information, and lack of crowd management. The location of safe zones have to be found primarily at places for where the most efficient evacuation happens. Considering the walking speed of pedestrians under different densities, the evacuation routes can be determined by calculating the capacity of different safe zones. For people sitting at different levels, some special technologies can also be used, like multiple exits and contraflow lanes.